Hey folks, and welcome back. This is CSE 1322, and today we're going to do the part 3 of module number 1. So in this lecture, we're going to talk about the different types of complex data types in Java, which is we're going to talk about some of the built-in ones like arrays, array lists, and strings. So let's get started. All right, so first off, we've seen that Java has 8 primitive types. We talked about this in the previous videos. The 8 primitive types are the 4 types of decimal numbers, which are byte, short, long, and int, and then the 2 types of floating point numbers, which are float and double, a char for holding a character, and boolean for holding true or false. Everything else that we deal with is going to be a complex type. So complex types are generally primitive types that have been built together to build something that's more complicated, hence complex types. And to put it another way, they are all objects. So today we're going to be dealing in object-oriented programming a whole lot. All right, so the first thing we're going to talk about today is strings. So in Java, a string is a complex data type. It's actually an object. And the first clue to that is the fact that string is capitalized. Int is lowercase. Generally, things that start with a capital letter, you're going to find out that they are objects. And so that will tell you that scanner, which you've seen, which has a capital S as an object, and also things like random is a capital R, so that's also going to be an object. So to declare a string in Java, what we're going to do is we're going to set up a variable, which in this case is going to be called color, and we're going to declare it as being of type string, and then we're going to set it equal to a color. So that gives us string with a capital S, color equals blue. And as we know, that's pretty simple, kind of works the same as it does in Java. There's really not much difference here, but it allows you to store a sequence of characters. If we think about this for just a moment, you'll realize a string is literally just a list of characters. The capital B is the first character, and L is the second, U is the third, and E is the fourth character. And in this case, they're always going to be surrounded by double quotes, unlike characters which have single quotes. And that's pretty much how you make a string, really, really simple. All right, so once you have a string, what can you do with it? Well, they're stored in objects, and an object can have attributes and it can have functions. And you've seen this in Python where you were able to build a class and then you were able to have variables. Works a little differently in Java, but they were there. And you're also allowed to have functions or methods inside of the class. And here is what we are going to do in Java. So you can access an attribute or call a method using the dot operator. And again, this is something you've seen before. So when we say string my color equals blue, we're then allowed to say size of color equals my color, that's the name of this variable here, dot length. And dot length in this case is a method call. We can tell it's a method because it has these parentheses at the end. All method calls will always have parentheses in Java. And so we're telling it that we want to call the method length in the object myColor. So myColor is an object of type string, which happens to have a method called length that will in this case return 4 because the length of the string is 4. So that's how you access a method inside of a object. It's basically just calling a method or a function. So here's another example. String example equals double quote test comma 1 comma 2. All right. So we can do a bunch of stuff with that. There's a bunch of methods that string automatically gives us. One of them is to uppercase, and that will give us back capital T-E-S-T, comma 1, 2. Obviously the commas, the 1s, and the 2s, they don't change, but all the letters will go from lowercase to uppercase. Likewise, there's to lowercase, which will give you T-E-S-T. Notice that the T was lowercased. In that case, everything is lower. Another useful one is called trim. In this case, it's not going to do anything, but if there are any extra spaces at the beginning or at the end, trim will automatically remove them for you. And this is very common when you ask somebody to type something in. They sometimes hit space by accident at the beginning or at the end, and trim will automatically take those back off for you. We've already seen a method called equals. We've mentioned this a couple of times when we were dealing with conditionals. We said if you're testing if a string is equal to another string, unlike in Python you cannot use equal equal, you have to use dot equals. So now you understand why. There's a method called equals which takes as a parameter a string and it compares it with the string in that its own object. So for example, and I'll just run out to a compiler here for just a moment. So this is just the boilerplate code. I'm going to get rid of that. And so we have, I have still extra stuff. Okay, we have string color equals blue, and then we have string other color equals red. So we want to see if these two are equal, which obviously they are not. So we would say if color, and what you would be tempted to do is this, but that's not actually going to work. You can tell straight away that Java underlined it, and it says that's always going to be false. That's not what you want. This is probably not what you're trying to do. So that's a clue that underline there is an issue. It's telling you that something is wrong, and then it's up to you to go figure out what is wrong. Okay, so how do we do this correctly? Well, instead of the equal equal, we say dot equals, and then in parentheses, we pass it the other string. And you have to spell equals correctly. There we go. So now it seems like that's also still underlying. Condition color equals is always false. Remove the if statement. Compares if the string, the object is true if... Okay, not really sure why it thinks that's always going to be false. I guess it can see that these are hard-coded. So let's do this. Let's add in a scanner. My scan equals, sing along with me, new scanner system.in, and we need to import Java util scanner. Okay, get rid of all that junk. Okay, there we go. So now we have a scanner. So now what I'm going to do is I'm going to, instead of setting the other color to always be red, I'm going to set it to myscan.nextLine. Now I'm also going to probably have to tell the user that they need to enter in a color. All right, so we're asking the user to enter in a color, and we're going to see if that color is always blue. So if I type in red, you notice that it says nothing because they're not the same. But if I run it again, and this time I tell it blue, it says they are the same. So to be clear what happened here, we have one string that's always blue, and now you notice that this is no longer underlined because the compiler cannot tell what I'm going to type in. So it doesn't know if they are always the same. It was underlining because they were the same, but they're no longer always the same. So just out of curiosity, let's check it the other way and see if it's still unhappy with that. Okay, so in this case, it's still underlined it, and it says string values are compared using equal equal, not dot equals. So it is barking at you about this, so be careful, look for those things. The general difference between a yellow underline and a red underline is if you're seeing a yellow underline, that means that it's a warning. It's telling you that something is probably wrong, but it can't really tell you that you can't do it. Whereas when you see a red line, it's not going to compile. It's telling you this is just not acceptable at all. So that's incorrect. The correct answer is dot equals. And notice that there is no space before that period. That has to be color dot equals, where color is the name of one of the strings, and the other name of the string is what's passed in those parentheses. And now we're back to correct again. All right, so equals tells you if two strings are equal. There's also a cool one in Java called equals ignore case, which will tell you if two strings are the same except for the case. So for example, if I were to type in blue here with a lowercase, you'll notice that it doesn't tell me that they're the same because, well, lowercase blue and capital blue are different ones. But if I say equals ignore, oh goodness, there we go, ignore case. Now all of a sudden if I run the same code and I type in lowercase blue, they are the same because it doesn't care about the case in this case. Yeah, that hangs together. All right, so let's look at some other options. We have length, which will tell us the length of the string that was passed in. So back over in my window, let's try that one. Let's print out the length of the string. You entered a string that is, and then what we're going to do here, the color they entered in was called other color dot length, and I'm just going to add in characters long. So when I hit run on this, it's going to ask me to enter in a, well, it's going to tell me that I forgot a semicolon. I did a colon by accident, so be careful about that. All right, so it's going to ask me to enter in a color. I'm going to type purple, and it says you entered a string that is 6 characters long, because again, PU PLE is 6 characters. So that's the length method. We also have a method called char_at, which will pull one character out of a string. So in this example, we have test, 1, 2. The first character is a capital T. And so char_at0 gives me the 0th character out of here. Remember that everything in computers is counted from 0. So the first position here is position 0, the next one is position 1, then position 2, and so on. So char_at0 gives me a T. By comparison, char_at1 would give me an E, a lowercase e. Char_at2 would give me an S. Char_at3 would give me a T. Char_at4 would give me the comma, and so on and so forth. If you want to get the last character out, you can combine these two, and you can say, give me the char_at the length minus 1. Now the reason you have to do minus 1 is because when it's asked for the length of this string, it's going to return 1, 2, 3, 4, 5, 6, 7, 8. It's going to return 8 for this string. Now remember, the char_at0 is this one, and this is char_at7, but that's still 8 characters because the 0 counts as one of the characters. So the length of this is 8, and so if I were to ask for char_at8, it's going to give me an error because the characters are indexed from 0. So it has to be char_at7, and that's why you need to do this minus 1 to get the last character. But this will always give me the last character, which in this case is the number 2. All right, if you want to pull out a part of the string, you have this handy function called substring, and it takes in 2 numbers. The first number is the starting position that you want it to return, and the last number is the ending position you want. It doesn't include the ending position, it includes everything up to that position. So in this case, 0, 1, 2, 2 is the starting position, so it'll give me an S, a T, because that's 3, 4, and then it doesn't include this 1 because that would be 5. So I get ST comma as my 2 to 5. If I did 2 to 6, I'd get ST comma 1. All right, and then we have split. This one's super handy. What it'll do is it'll take a string and it will break it up into 3 separate strings in a list by what you know from Python. So you can see here it gives me test, and then it gives me a 1 and a 2. It doesn't include the comma because I told it I want to split it based on the comma. So the comma is not in any of the strings that it returns. The first one is the word test, the second one is the number 1, and the third one is the number 2, but each of those are stored as strings. They come back as strings. So this returns to you what's called an array of strings, kind of like a list of strings. We'll talk more about that in just a few minutes here. And then finally we have example.toCharArray. We've seen this one in an earlier example when I was trying to use a for loop to iterate over a string. You can do that inherently in Python. You can just say for x in string name and it'll work. Here you had to say for char_x colon string.toCharArray. And what this does is it converts the string into a character array, and we're going to talk about arrays here in just a moment. So bear with me on that. We'll come back to character arrays in just a few seconds. All right, so let's start talking about the different types of collections. So you guys are used to Python, and in Python you had lists, which were denoted with the square brackets, tuples, which were in the parentheses, and sets, which were in the curly braces. And they each have their place. In Java, we have a slightly different set of collections. A collection is simply just a group of things put together as a single item. And so in Java, we have an array, which is similar to a list insofar as it can have a list of things in there, but it is fixed in size, which is very different than a list in Python. In Python, you start off with a list, there's nothing in it, you start adding things to it, and it just grows as you need it to. So if you put in a name and then another name, it's 2. If you put in a third name, it's of size 3. With an array in Java, you have to tell it up front how big you want the array to be, and then it can only ever be that size. You might think that's really limiting and weird, and why do we have that? We'll see that there's some uses for that coming up in a bit here. If you want something that's more like a list in Python, you're going to be looking for something called an ArrayList in Java. And this allows you to shrink and grow automatically just like a list does. It can only hold a single type at a time, which is a little bit different than your Python world. So when you declare the ArrayList, you specify what type is going to be in there. It's an array list of strings. It's an array list of integers. And then at that point, you can only put strings or integers into the array list. Whatever type you declare it as, that's what it must be. Again, we're strongly typed. So there are other collection types that we're going to see later on, but we're going to talk about these first. So let's start off with some comparisons between the two. So in Python, we might have a list here, name equals Alice, Bob, and Eve. So 3 items in the list. Each of those are strings, obviously. And then we can use a for loop that says for person in name and print person, that would print Alice, Bob, and Eve, one each on a line. So the equivalent of that code in Java is going to be a little bit longer. So the first thing we have to do is we have to import ArrayList. So much like we were importing scanner or random in some of the earlier examples, ArrayList is something else that has to be imported. You will notice they are all imported from Java util. So java.util.ArrayList is what you're importing here. It was java.util.scanner and java.util.random. So you're noticing a lot of things are in java.util. We'll deal with other options later on. All right, so then the way you declare the list, again, in Python, you don't have to specify what type. In Java, you do. So you're going to say ArrayList, and then you're going to use angle brackets. This is a little weird syntax here that we're going to talk through. You're going to give it a variable name. Names is what I called it. I called it name here and names here for some reason. Equals new ArrayList, and then in angle brackets string, and then parentheses at the end. So way longer than it was over in Python. So what you're saying here is you're making an array list of strings. That's what this angle bracket thing is. You're specifying the type that you want the array list to be of. What has to be in those angle brackets is what's called an object type. String is an object type. You cannot put int in there because that's not an object. If you want an array list of ints, you have to say integer. I'll explain that later. But inside of here, you're going to have angle brackets and the type that you want the array list to be of. This means that each cell in the array list, or each bucket that you can put things in, can hold one string each. The array list can hold an unlimited number of those together. The names here is just the variable name. So that could have been Fred or Bob, or it could have been X or A or B. You can call it whatever you want, but in this case I'm storing a bunch of names, so maybe it's nice to call them names. And then this weirdness of equals new array list, this is because you're creating an object. And we're going to pause on this for just a moment and talk about this. So you've seen this a couple of times now, so I feel like I owe you an explanation. Up here we have scanner myscan equals new scanner. And what I've just shown you is ArrayList string names equals new ArrayList string and a semicolon. And again, it's highlighting it in red because I need to import Java util ArrayList. Okay, so what's in common between these two lines? Well, there's a type, which in this case is scanner, and in this case is ArrayList of string. Then there's a variable name, which I've told you in both cases can be whatever you want to call it. In this case, the scanner I called myscan. In the case of the ArrayList, I called it names. And then there's an equals new, and then we're repeating the name of the object that we're creating again on the right hand side. So scanner equals new scanner, ArrayList equals new ArrayList. For the most part right now, you can assume that anytime you create an object, you're going to start off with the type of the object, a variable name, equals new, and the type of the object again. You'll see that there's occasional moments where that's not true and you're going to do something different, but we're going to talk about that later. Right now, assume it is the object name, a variable name equals new, and then the object name. In the case of the array list, the object type was ArrayList string, and what you called for new of was ArrayList string. And you'll notice that after the new, there's always going to be parentheses. Sometimes there's something in those parentheses, like system.in. Other times the parentheses are empty. When you make an array list, you're generally going to leave it empty. When you're making a scanner, for now you're always going to type in system.in. We'll see there's other options later. So ArrayList string equals, or ArrayList string names equals new ArrayList string. So it's not really as scary as it looks. You're just repeating the type, which happens to be a big long thing. On both sides, you always have these parentheses. You have the new keyword, and then you also have the variable name. Once you've made it, to put stuff in an array list in Java, you use the add method. So names is the name of this variable. Names.add Alice will put an Alice into the array list. So the way that you can picture this is you can imagine that you have, and I'm just going to draw this, you can imagine that you have this big long box like this, and in the first cell of the box, which is labeled cell 0, you now have Alice as a string, so double quotes around it. All right, and so that's what has happened on this line here, names.add Alice. When we do names.add Bob, then effectively what's going to happen is into cell 1, we're now going to add Bob. And right now the rest of the array is really not there, so if I was accurately drawing this, I'd really look more like this, because that's all that's in the array list at the moment. And the name of this array list is names, so that's really what we have. Names is just this list that has two things in it. One of them is Alice and the other one is Bob. Okay, and now we're going to add Eve, and of course all that that's really going to do is it's going to add another box on, and we add Eve in there. Okay, so that's adding three different things in. At this point we're going to do a for loop. In the case of Java, this is actually really a for each loop, but they are written as for. And so what we're saying is, for string person in names, this is read in even though it's a colon, you're going to pull out one name at a time, assign it to person, and then print that person. So what this is going to do is, looking at the array, it's going to take this first name, Alice, it's going to assign it to the variable name person. So person is initially equal to an empty string. Those are double quotes. And then when it does this loop, it's going to take Alice and it's going to put Alice in there. So it's now initially equal to Alice and double quote. Okay, so that is how it's going to store person, and then it's going to go through and it's going to execute all the code inside of the loop, which simply just prints out Alice. Once it gets to the end of the loop and it comes up to the top, it will automatically pull the next name out of names and assign it to person. And so in our picture, it's already done this one, so it's now going to move on to Bob, and it's going to assign Bob to person. And so person is no longer Alice, it's now Bob. And then it runs all the loop code, which is just to print out Bob. And then it gets to the end of the loop, it goes back to the top, and again, it moves the next name in, and so it's no longer Bob, it's now Eve. It prints out Eve, because that's what the print statement says to do. It gets to the bottom, it comes back up to the top, and now there's nothing left. There's nothing over here for it to use, so it's done. It has assigned all of the things in the list, and the for loop is going to end, and you're going to move on with whatever code is down below the for loop down here, which there is nothing. All right, so these two are identical in functionality, but they're actually working quite differently. The array list on the Java side is strongly typed. You had to specify that it was containing strings, and if you try to put something in there that is not a string, it's going to get very angry at you. If I go over to my Python window and I get rid of some of this other stuff, and I simply try to say names.add and I put the number 1 in there, you can see it immediately highlighted it. When I try to run it, the strongly typing is going to come back and it's going to say, you can't do that. Incompatible type, int cannot be converted to a string. So it knows that this is an array list of strings. I tried to put a number in there, that's not allowed. But if I try to put a name in there, and the name of course can have a number in it, we're naming somebody x1, it's perfectly happy with that. The code does nothing because I didn't do anything with it, but I'm now happily able to put that in there. So that's how you use an array list in Java. It works somewhat similar to a list in Python. The idea is really the same, but the syntax is slightly different. The other thing you might wonder is, how do you create it with the code, with the values in it automatically? There is a way to do that, but it's a little bit more complicated, so we're not going to talk about it right now. Generally, you're just going to use the add method to get them in there to start off with, and later on we'll see other examples where you can initialize it with code. All right, so in the end, an array list is a linear data structure. We say linear because, again, when we drew it out, we picture it as being in a in a straight line. And so if I can ever figure out how to change the color here, there it is. Effectively, we picture it as being in a straight line like this because that makes sense in our head and it's linear. We're adding new things on this end and they're all connected together as a single thing. As items are added, it grows to the necessary size. As items are removed, it shrinks. Like arrays, they're indexed from position 0, and it's much like a list in Python. So to be 100% clear, this cell is cell 0, and this cell is cell 1, this cell is cell 2. They are indexed from 0. That is important to remember. Because you can access them with a get method. So we've talked about the add method. There's also a get method, which allows you to pull something back out again. Okay, so the next thing to talk about is the different types. So I mentioned that if you wanted an array list of string, you do array list and then in angle brackets the word string with a capital S. And that works because string is an object. But again, I mentioned you cannot put int in there because int isn't an object. This is a weird artifact of Java, and I don't know what to tell you other than I think they kind of messed up here. It's supposed to be an object because the whole language is object-oriented, but somebody decided it wouldn't be an object because reasons. And then they got to array lists and they were like, but this has to be an object, so what do we put in here if we want an array list of integers? And the clever solution was to create something called integer with a capital I, which is a wrapper around integer. This is an object that wraps around the primitive type int. And so there's one of these for each of the primitive types. There's a double with a capital D, there's a boolean with a capital B, boolean with a capital B, there's a car with a capital C, and so on and so forth. So integer is the wrapper around it. Integer is the only exceptional one because you actually spell out integer. Not only is it a capital I, but you also spell out integer. Because reasons. I just work here. So anyway, integer is the type that you use if you want an array list of ints. You specify the type that you're going to store in those angle brackets. It must be of type object, so int is integer, double is double, etc. All right, so let's talk about the array list methods, the fun part of array lists. So we have add, which we've seen, and that's how you put something into the array list. So here we have an array list of strings called myArrayList, and so myArrayList.add Alice will put Alice into the array list. Add can also take a second parameter. If you want to add it in a very specific cell, you can put a number at the beginning and it will tell you, or you're telling it where you want it to put it. By default, it's always going to put it in the next available cell. So assuming that there's nothing in the array list, so to be clear, we're dealing with something that looks like this, and so we're just going to clear all this off here. It's fun watching me erase, isn't it? Okay. Oh, that's not erasing on your screen. There it is. It's all gone. Cool. All right, so when you start off, you called it myArrayList, and initially it's empty. There's nothing in it, so effectively you would picture nothing. When you do an add on Alice, it put that into cell 0 as we saw, and if you do another add, it puts it into cell 1. And what I mean by that is it always puts it in the next empty cell. If I do another add, it's going to put on a cell 2, and it's going to put whatever I put in there. So it's always adding into the next available cell. If you send a second parameter to the add, like they did here, like they said add 0 Bob, then that would actually put Bob in at 0. And so instead of putting it in at 3 right now, it's going to put it in at 0. And so that's going to be for adding stuff in a weird cell. Honestly, you're not going to do that very often, but it is possible. All right, so if you want to see if the array list contains something, in Python you had a contains, and same thing appears here, or actually you have in Python, which will tell you whether something is in a list. So here you do ArrayList.contains, and then you tell it what you want it to search for. So this will either return true or false, and it will tell you whether Charlie is in the list. The next thing is get. This will return something out of the list. So for example, if you want to know what's in cell 0, you do myArrayList.getZero, and in our case that would be Bob, because that's what we just put into cell 0. MyArrayList.size. Okay, this one you're going to always forget because Strings, when you want to know how big they are, you ask for dot length. Array lists, you ask for dot size. That is what it is. All right, ArrayList dot set 1 to David. Okay, so when you do an add, it adds in the new element, leaving the existing elements in there. It kind of pushes them all over. But if you do a set, it replaces the value that was in that previous cell. So now cell 1 contains David instead of containing Bob like it used to. Likewise, if you want to remove something out of a cell, you do remove and you pass it either the index that you want to remove, or you can pass it the particular item you want it to remove, and it will go find it and remove it. So in this case, it's going to take out whatever's in cell 1 and you don't get a vote in it. In this case, it will find the first occurrence of Bob and remove it out of the list. All right, a couple of other things that we haven't mentioned. Dot clear, which will clear the list, takes everything out of there. Dot is empty, which will return true or false, which will tell you whether or not the list currently is empty. So when you just create it like you did a myArrayList.isEmpty here, right at this line, it would return true because it is currently empty. All right, the last thing to mention down here is that array lists start with a capacity of 10 and they grow as needed. What does that mean? Okay, so let me erase all of this again, and then let me explain. So, assuming that I said my array list equals new array list. So array list, and then angle bracket string my list equals new array list string. And then you have to have those parentheses there and then the semicolon. Okay, so that's how we declare it. At this point, what we have is we have my list, and what it actually has done when you did this is it made an array list like this. It already has 10 cells pre-allocated for you. I miscounted. All right, so this last cell is just not here, so pretend that's not there. A smarter person would erase it, but here we are. Okay, so what's in all of those cells? At the moment, it's literally something called null. Because string is the type of the array list, and we know that because of this line up here, every one of those would have been initialized to null, that's N-U-L-L, automatically for you in Java. Anytime that you create a string in Java, if you haven't set it to something, Java automatically sets it to null. I'm just going to rewrite that so it's a little clearer. There we go. All right, so in reality, they're all null. If I looked in each of these cells, they're null. If I ask this array list right now, is it empty? It will say, yes, it is empty. If I then do an add Alice, we know that what happens is that it replaces what's currently in the first cell with the string Alice, because that's what we told it to do. So what's interesting here is all of the other cells are there, and they're all empty at the moment. So all of these are here, but they have nothing in them. So assuming that we fill other things into the array, so let's assume that I put something in cell 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So all of those cells now have a name. This one is Bob, and Charlie, and David, and so on and so forth. When I go to do the next add, the array is already full. So what does it do? Well, the answer is with an array list, we know that it can grow infinitely, because I told you that at the very beginning. And so what it secretly does in the background, without you knowing it, is it creates an array list that is time and a half the size of the previous array list, which would be 0 to 14. I'm not going to count out those cells, but you can believe me, there's 14 of them there. So time and a half, because it's whatever the size was originally, which is 10 cells, plus half again would get you to 15, which is cells 0 to 14. We know that this one has Alice in it, and we know that these are all full, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They all had values, and I had done one more add. That's what caused it to create this new thing. So the new value gets put into that 10th cell. And it'll continue allowing me to do adds, which will go in 11 and 12 and 13, I got the right number, and 14. Everything will be magical and fine until I do another add when 14 is full. At that point, it will increase the size again by time and a half. So currently there's 15 cells, so it's now going to be 22 cells. And it'll continue doing that each time you exceed the boundary. So that's what it means when it says that they start off with a capacity of 10 and it grows as needed. To be clear, over in Python you might say, well, I never had to think about any of this. This is a bunch of crazy. Why would you do all of this? Just make the list dynamically grow. Python was doing the same thing. We just never talked about it. A lot of stuff magically happens in Python, and we want it to be magical for you in the first semester. We no longer care that it's magical. Now we care that you actually understand how it's working. So the capacity really does start off at 10, and then it just grows it as it needs to. There are some things that are a little easier when you're in an interpreted language that makes some of this better, but overall the same idea is having to happen in the background no matter what the language is. So when you see something is magically happening, you probably need to ask yourself, how is that happening? Because it's important to understand what's going on under the covers, because there are ramifications to this. Each time that the array list has to grow, so each time we go from this 9 sized array list to this 14 size array list, literally in the background, when you did one more add, so you just did add Fred, that seems like that was one thing that the computer had to do, but it wasn't. It actually had to make this new array list. It then had to copy down all of the values from the old array into the new array. And then when it was done with that, it then and only then was able to add in your new value into cell 10. So adding in the first value, Alice, was one operation for the computer. Adding in Bob was one operation. Charlie was one operation. David, Fred, Edgar? Anyway, all of these were one operation until you get to this 10th one. When it tries to do the 10th one, all of a sudden, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 operations to insert this one. Now you might say, okay, why do I care? Because this insert took a lot longer than all of the other inserts. And you probably don't notice it because, again, your computer is able to do billions of things a second, so it doesn't really matter. But every time it has to regrow the list, it's going to have to do all of that work again. And right now it only had to copy 10 things because we were growing from 10 to 15. The next time we're going from 15 to 22. There will come a moment where you have 1,000,000 cells and you need to grow to 1.5 million. And in order to do that next insert, it's going to need to do 1,000,000 operations to copy the original array down into the new one before it allows you to do the insert. And you're going to notice that it's going to take fractionally longer of a second than it previously was taking to do the other inserts. And when you get to 1 billion and it has to do 1 billion operations, you're really going to notice that. So what I mean is, you're calling this add method and it's working and everything is great, and then sometimes it freezes. And you're like, I just did an add. You've done this 10 times. Why is this harder? It's because there's all this behind the scenes work that it's having to do to make the array list be the right size in order to deal with your thing. So, other footnotes on array lists. Does it ever shrink? So if you take out the 11th item, does it go ahead and move it back to 10? And the answer is no, it doesn't. It won't automatically reshrink. It will always stay the size that was the maximum size it ever grew to, unless you specifically tell it to. And the reason they made that decision is because it's work to copy all that into a smaller structure. And so doing that work, unless you have to do it, it's just better off to leave it be. So weirdly, array lists, we say they dynamically grow and shrink to meet what you want, but in reality, they're not really dynamically growing and shrinking. There's just this clever thing that's happening in the background that's making it bigger when it needs to be bigger, and not really ever making it smaller when it needs to be smaller. We think of it as being smaller, but it's not. So what I'm telling you is, if you did 1 million inserts into an array list, the array list will have 1.5 million cells, And then if you remove 999,999 of those, the array list will still have 1.5 million cells. And you might say, okay, I don't care. Why does this matter? Why are you still talking about this? Move on. The answer is it's actually using memory. And that memory never got freed back up. So your Java program that you're running in IntelliJ is actually consuming memory on your computer. You bought your computer with 8 gigs of RAM or 16 gigs of RAM or whatever you have 16 million bits of RAM that you can use. So when you create an array that has 1 billion cells or 1.5 billion cells, it's using a gig of RAM. Literally. So of your 8 gigs that you bought that's supposed to be running Chrome and your game and your music player and the 50 other things you've got open right now, 1 gig of your RAM is being used by Java in order to hold an array list that's got 1 item in it. So array lists growing and shrinking, it's not magical. It's actually something that you have to think about what it's doing in the background, and there are times where they're maybe not the best structure because of that magical growing and shrinking. Okay, so enough on that topic. Here we have another example. We have an array list of integers, and we're going to put some integers in here. So we're using a regular for loop, I equals 0, I less than 5, I plus plus. That's going to do 0, 1, 2, 3, and 4. It's not going to do 5 because that's not less than 5. So 0, 1, 2, 3, and 4 are going to get added into the first 5 cells. Never had to grow the array list this time because you didn't use more than 10. And then our for each loop, which is what this one is how you would print them back out again. So it's saying for each integer x in the list, this is my list, you're going to print out the x, which is the value that was assigned from each cell of my list into the x. So again, this is like the for loop in Python, where you said for x in my list. This is the same thing, you're just saying for int x, because you have to declare the type, and this is read in, even though it's a colon, my list, print out x. All right, so hopefully that makes sense. So that's array lists. Let's next talk about arrays. So arrays are very similar to array lists, but they're more limited. They're a fixed size, and you don't get to automatically grow and shrink them. They cannot be sliced. They can hold only a single data type, and again, they're a fixed size. So why would you ever use this? It's kind of like an array list without all the fancy features. And the answer is because you know exactly how much space they're occupying, and you're guaranteed that they're never going to grow outside of that size. Now, let's talk about this memory management stuff. I've hinted at the fact that your computer is 8 gigs of RAM and maybe you're using it and blah, blah, blah. We're back to that again. You might say, well, I have loads of RAM. I don't care. It doesn't matter. I'll just buy more RAM. There are a lot of devices where you have a very limited amount of RAM. Believe it or not, on most embedded systems, which is what's going to be happening in a toaster or in a video, in a TV or in a projector or something like that, there's a very limited amount of space available. And that space, once it's used, you can reclaim it as long as you give it up, but you can't store anything else while you're using the space. So you have to be very careful about that space. And when I say very small amounts, sometimes you'd be shocked. Like some devices like airplanes might literally be flying with only 8 megs of RAM because the embedded system was designed with a very small amount of memory. And you have to be very careful about how you use that RAM, and just randomly allocating something that's 1 million cells, well, that's going to be the entirety of the RAM. So probably don't want to do that. So, got to be careful about what you're using. Arrays are a fixed size, and the other thing that's nice about arrays is that they can be multidimensional. So let's take a look at this. This is the syntax for an array in Java. So you don't have to do the crazy thing where the capital integers here, you can just do an array of ints. So you'd specify the type, and if I didn't have these square brackets, what I would be doing is I'd be making an int, a variable, which is of type int. But the square brackets imply it's an array of integers. It's kind of like a list, but it doesn't grow and shrink. So I say int square brackets, I give it a name, and then I say equals new int, and then in the square brackets this time I specify how big I want it. So what this did was it created an array that has 10 cells, and each cell can hold a number. And so if we were to think about this much like we were thinking with the array lists, it's going to look very similar to the array list. We're going to picture it as a straight line, said he, discreetly erasing the board on the other side. And so what we're going to do is we're going to flip over to that screen, and there we go. Okay, so what this created was, again, something that looks like this. It looks identical to the array list, 0, 1, 2, 3, 4, 5, 6, 7, I miscounted, 8, and 9. Okay, so this was called my int array. All right, and each one of these cells, so when I say cell, what I'm speaking about specifically is this is a cell. Each one of these cells can hold a single number. So I can put any integer I want in here. So, 0, I could put a 52 million, 53. I can do any number I want. It can be negative, so -7. It's perfectly fine, and so on. But they can only hold one number at a time. So much like in a list, each cell holds one thing. The difference is there are 9. We don't get the nice add and remove functions like we have in the array list. You have to do all of this manually. So this line of code, int square brackets my int array equals new int square brackets 10, created this structure. And then if I want to put things into it, I use the square brackets in order to specify what it is that I want to put in there. So if I want to put something, if I want to get something out of the array, I use the name of the array, square bracket, the position, and then I can put that in a variable. If I want to put something in the array, I use the array square bracket position to put stuff in there. So if we go back to my example over here, if I want to put the number 6 into that cell, oops, I'm not in a pen mode, there we go. I want to put a 6 into that cell. The way that I would say that is my int array, that's the name of my array, at square bracket 4 is equal to 6. Okay, and that's going to put that 6 into cell 4. So remember there's two different values here. There's the index, which is what this part is called. That's the index. And then there's the value that you're putting into it. The value is what's going in the cell. The index is the identity of the cell so that you know which cell you're talking about. So the name of the array, square brackets, the cell number equals to some value is how you put stuff in. And the same works in reverse. So I can say int biggest is est is equal to my int array at square bracket, in this case 4, because that is the one that has the biggest value, and there's a semicolon at the end there. So that's pulling out this value, that's my int array at value at position 4, and it's storing it in a variable called biggest. So that's what's happening on this slide. This is how you read values out of it and put values into it. So let's go over to a compiler window and let's make ourselves an array and let's start sticking some stuff into it. So int square bracket my array equals new int square bracket 10. So that gives me 10 cells. So I can certainly say my array at position 0 is equal to 2, my array at position 1 is equal to 3, my array at position 2 is equal to 4. Okay, so that's one valid way of doing it. I can also put those values in at the time I create the array. So I can say int my other array, this makes me a second array, equals new int, and this time instead of putting a value in the square brackets, I leave it empty, and then afterwards I put a set of curly braces and I can just put my values straight into the array that way. I don't know if that's the right number. That's going to be 2, 4, 6, 8. It will make an array of size 8 because I gave it 8 values. And just to prove that, I'm going to print out my other array, oops, not in double quotes, at position 3. Okay, so I want you to think about this for a moment before I hit run. Position 0, position 1, position 2, position 3. So this is going to print out 6 for me because that is what's in cell number 3, and there's the 6 indeed. All right, so this is how you, both of these create an array and put values into them. You can certainly do it this way. You can also do it this way. Very often, if you're going to do it this first way, you'd actually use a loop. For int I equals 0, I less than 10, I plus plus, my array at position I is equal to I plus 2. I don't know. So that's going to take I, which is 0, add 2 to it and put that in cell 0. And then put a 3 in cell 1 and a 4 in cell 2 and a 5 in cell 3. And just to prove that point, I'll print out my array at position 4. So what do we think is going to be in position 4? I believe we're going to get another 6, because the first cell, cell 0, ended up with 2. The next cell 1 ended up with 3. The next cell 2 ended up with 4. So cell 4 would have ended up with 6 because of this I plus 2. All right, and likewise, if I print out cell 9, we will see that I will get 11. So it'll be 11 and then 6. The 6 is coming from this other one down here, but that's the 11 that tells me the answer. All right, things to be aware of. You have to be very careful with arrays that you never ask for anything outside of the size of the array. So if I ask for cell 10, please note that it is going to crash. Index 10 is out of bounds for length 10. And that's because the array does have 10 cells in it. That's what I asked for, but they're numbered 0 through 9. And then I asked for what's in cell 10, and it said, you can't. There is no cell 10. You get 0 through 9. So make sure that you're using the correct values. Likewise, you can't look in cells -1 or cell 52. It's only cells 0 through 9. All right. So, using a loop, keep prompting the user to enter a number. Store each number in the next cell of an array. If the user enters -1, or if the array is full, stop asking. Print out the smallest of the numbers that were entered, excluding the -1. Again, I want you to pause the video right now, and then when you come back, we're going to take a look at what a good answer is. So you're going to keep prompting them for information, and then we're going to go from there. All right, so welcome back. So what we're going to do here is I'm going to erase all of what I have, and we're going to start over. So the first thing that I'm supposed to do is, using a loop, keep prompting the user to enter in a number. Okay, so we first off have to decide how big is the array going to be. And in fairness, this doesn't tell us, so I'm going to add that to the slide. At some point here, I'm going to say using an array of size 10, just so that's a little bit more. All right, there we go. Array of size 10 that holds ints. Cool. So the way we do that is we say int, square bracket, call it anything, I'll call it x this time, equals new int, square bracket 10, that's an array of size 10. All right, using a loop, keep prompting the user to enter in a number. So I'm going to prompt the user at least once, right? I'm going to ask them to do something, so I'm going to use a do loop here. And I'm going to say print enter a number, -1 to quit. All right. Then I'm going to read in a number. Now, in order to read in a number, I need my scanner. So sing along with me. Scanner, my scan equals new scanner system.in. Okay, so in order to read in a number, we're going to say int user number, call it whatever you want, is equal to my scan.nextInt. That reads in a number. And I'm going to keep doing this while user number is not equal to -1. All right, and there's a semicolon at the end. Now, you can see that it's unhappy with user number, so let's debug this first. It says cannot resolve symbol user number, and you say, but it's right there. I declared int user number, one line above it. Why can't you see it? Remember the rule about where variables exist? They only exist within their enclosing curly braces. So this user number actually only exists from here to here, which does not include the while statement. So if I want to do this, I actually have to declare user number before I go into the loop. And then I don't say int here, I just use it. And now it's happy, right? You notice this is no longer in red. So this will keep reading in numbers. Each of them is stored in a variable called user number. But what I'm supposed to be doing is I'm supposed to be adding them into the array. So to put them into the array is called x, and I have to specify what position I want to put them, so we'll come back to that in a moment, but we're going to put in user number into that. Now it's not happy with this. You can never specify x and not put a number in here. You have to always specify one position. There's no way to talk about the whole array at once. You have to talk about one cell of the array. So what I'm going to do is I'm going to make another variable. I'm going to call it index, and I'm going to set it equal to 0. And then I'm going to say x at position index is equal to the user num. So that's going to always put the value that the user gave me into cell 0, which is not quite what I want. So I need to change that. After I've put in a value, I'm going to do an index plus plus. All right, so let's run this and let's talk about what's happening here. So first thing that happens is it makes for me, well, it tells me that I'm missing a semicolon. I did a colon again. This keyboard is weird. All right, so the first thing it does is it makes an array which is called x that has 10 cells that can hold integers. It sets up a variable called user number, and a variable called index. It then prints out enter a number, and that's what we can see on the screen here. So I'm going to type in a number. I'm going to type in 15. And what happened was it set a variable called user number equal to 15, because that's what I typed in, and that's what it gets from this next int from the scanner. So now user number is 15. The next thing that happens is I set x, which is the name of my array, at position index, which right now is 0, because that's what it was set to be equal to 15. So that put 15 into the first cell of the array. And if we go back over to our picture, effectively what's happened here is we've put 15 in here. All of the other cells are still currently empty because I haven't done anything with them yet. So the array basically looks like this, except it's not called myIntArray. In this case, it's just called x, because that's what I called it. Okay, so that's what I've done so far. At this point, and let's keep track of a few other things on the screen here. So we have a few other variables that we should talk about. We have index, which right now is 0, and we also have user num. Is it user num or user number? Number, which was 15. So those are all the variables that we are dealing with so far. Our x array has 15 in there. Okay, so back to the real time here. Index gets index plus plus. So that means that whatever the current value of index is, it was 0, it now becomes 1. That's what a plus plus does. Great. We've hit the bottom of the loop, so we're going to test our condition. While user number is not -1. Well, our user number right now is 15, so that is definitely not -1. So we're going to go back up to the top of the loop again, because this is true. It is not -1. All right, so back to the top of the loop, it's going to print out enter a number, and that's indeed what it did. Then it's going to try and wait for me to type in something, which it's going to store in user number. So this time I'm going to type in 9. I'm going to hit enter, and what really happened here was user number became 9, and then we're now going to move on to the next line, which says x at position index, so that's x, which is this array, at position index, which is currently 1, that's right here, is going to be equal to what I just typed in, which is user num, which is the number 9. And so we're going to put a 9 into that second cell. Okay, index plus plus, so our index is no longer 1, it's now 2. All right, back to the test. While user number, which is currently 9, is not -1, which 9 is not -1, we're going to go back up and do the loop again. It's going to prompt me for another number. I'm going to type in the number 7, and what's going to happen is a 7 is going to get filled into here because it's putting it into the array at index. Index is currently 2, so a 7 gets put in to cell 2. All right, then index is going to get plus, so it goes to 3, and we're going to keep doing this. All right, it's going to keep asking me to enter in numbers. At this point, it'll go forever, but we'll eventually run into a bug here. So notice this program is running. I'm going to put in the number 8, and what that's going to do is it's going to put an 8 in here, and this is now 4. I'm going to type in the number 9. This is now going to go in here, and this is now equal to 5. I'm going to type in the number 10. That's going to go in here. This is now 6. I'm going to type in the number 11. That's now 7. I'm going to type in the number 12. Oops. That's going to go in here. This is now 8. I've run out of room, so we're going to open another line. I'm going to type in 13. Goes in here. This is now 9. All right, we're going to go back to tracing again because interesting things are about to happen. So this time I'm going to type in 14. And so at the moment, according to all of this, our index is 9. So when I type in 14, it's going to say x at position index, so x at position 9 is equal to 14. That's indeed going to put the 14 into this cell, and life is going to be good. All right? So then it says index plus plus. So that's going to change the 9 to 10. Now you can see what's about to happen. We get to the bottom and it says, is the user number, which was 14, not equal to -1? 14 is not -1, so we go back to the top. It's asked me to type in a number again. And when I type in whatever number I type in, so I'm going to type in 15, with the moment I hit enter, it's going to read 15 in, it's going to put it in user number, that's fine, that's going to work, but then it's going to try and set x at position 10 to 15. And that is not going to work. Why? Because there is no position 10 in the array, and the array cannot grow because it's an array. So it simply says index 10 out of bounds for length 10. The length of the array is 10. There is no index 10 because it's 0 through 9. So this program currently has a bug, which is that it keeps going regardless how big the array, regardless of how many numbers the user enters in. It's assuming the user will enter a -1 before then. And just to prove a point, if I do give a -1 at the very beginning, or let's say I do, the number 2 and then I do -1, the loop did end, right? The code finished at that point because the while loop correctly exited. The issue was when we keep going, we only have 10 cells in the array because that's what we specified, and then we could get to the point where we're trying to insert something in cell 10. So the reason for this is because we didn't do the other part of the question, which was keep prompting the user to enter a number, store it in the next cell of the array. If the user enters -1 or the array is full, stop asking. Okay, so while the user number is not -1 and index is less than 10. All right, I'm going to have to put another set of parentheses around this because the while condition has to have an outer set of parentheses, and then each of the individual terms you should put a set of parentheses on it. So in this case, I did an and remember with an and, both things have to be true in order for this to continue. So the way this works is if they give me a -1, this is false, false and anything is going to be false because they both have to be true. If the index reaches 10, which is not less than 10, this is false, and at that point the whole thing is false, which will stop the loop. So either of them will stop the loop. So now if I were to rerun it, and I'm not going to go through all of it in painful detail, but what I'm going to do is I'm just going to type in 1, 2, 3, 4, 5, 6, 7, 8, 9. When I do 10, the loop exits. And it gracefully exited, it didn't crash. So that's the other part of this. All right, so the next thing I'm supposed to do after all of this prompting is I'm supposed to ask the user, I'm supposed to tell the user what the smallest number that they entered was, excluding the -1. All right, so a couple of things in here. All I really need to do is I need to keep track of a smallest number. So before I start, I'm going to say smallest is equal to, let's say, 1,000. All right, as I go through the loop, when I'm putting in each value, I'm going to add an if statement. I'm going to say if x at position index is less than smallest, then change smallest to be whatever is in x at position index. Okay, so basically whatever I just put in, the usernum, I could have done usernum instead of x at index here and it would have been the same. Whatever the value was the user just gave me, if that's less than the current smallest, then change smallest to be that new number. And that's going to keep track of the smallest. So outside of my loop here, I'm going to print smallest is, and then plus smallest, because that's the variable that's holding the value. Okay, so we're going to run it and we're going to test this. First thing we're going to do is we're going to enter in 10, and then 20, and then 30, and then -1. And it says the smallest is -1. Okay, so why did that happen? Well, indeed, of those numbers that I typed in, -1 is the smallest. I did type in a -1. It put -1 into the array because it always puts whatever number I give you into the array. It's only later that it realizes the loop ended. But it asked for a number, I gave it -1, it put that -1 into the array, and then it checked if -1 is smaller than the smallest, and at that point it changed out smallest to be -1. And even if -1 had happened somewhere differently in the list, which it can't because the loop would have ended, it would have had -1 being the smallest. So I need to not check, I need to be careful that if it's a -1 I don't count it. So if x at position index is less than the smallest and x at position index is not equal to -1, that's one way of solving this problem. There's many ways to solve it. That's not the only way, and it's probably one of the less intuitive ways, but let's try this again. So 10, 20, 30, and -1, it says the smallest is 10. Great, because the -1 didn't get counted here. The reason I said there's a lot of ways to solve it, you certainly didn't have to do this if it's a -1. So you could put an if statement on this that says, if user num is not -1, then do this, and that would solve it as well. There are other solutions. So will this always work? Well, mostly, but there are a couple of problems here. And this is where testing becomes very important with code. I made smallest equal to 1,000 at the very beginning, so what happens if all the numbers are bigger than 1,000? 1,002, 1,003, and -1. Well, it says the smallest is 1,000, which I never entered. I never put 1,000 in there. The smallest is 1,000 because 2001 is not smaller than 1,000, and 2002 is not smaller than 1,000, and 2003 is also not smaller than 1,000. So in actuality, 1,000 is still the smallest. So, I mean, I can fix that by making this 10,000, and that works, but the problem that you're going to have now is what happens if they type in 10,001 and 10,002. It still says it's 10,000. So we always are going to have this problem. So there's a magical thing called integer.maxValue. And what that does is it takes the biggest value you can possibly store in an integer and it stores it in smallest. So now, if I run this and I give it 1,000, or let's do 100,052, 100,053, and a -1, it successfully finds that that is there. I've eliminated this problem. And since I started off with the largest possible value that can be stored in an integer, this can never be wrong. So that's how we could solve that problem. The other way to solve the problem is whatever value they give you first, put that in smallest. And then you can check and see whether any of the other ones are smaller than it. Okay, so here's an example of the code. This is similar to what I just wrote, but it just gives it to you in a slide so that you can copy and paste it if you want to play with it yourself. This reads in the numbers, it puts each of them in. If the number is not -1, it puts it in the array and increments the position. And then I use a separate loop to find the smallest one here, just to give you a little bit more practice with the loops. All right, and so this is just running the code. This is it putting in some values. So it looks like they enter in 17, then 5, then 22, then 1, and then -1. And when they enter in the -1, we hit the end because we're hitting a break there. And so that break is then going to cause us to start the other loop. And in the other loop, we have smallest is in whatever's in the first cell. And then we do for I less than position I++. So this is going to move through all the numbers. And it's going to tell us that 1 is the smallest because 1 is the smallest. All right. It's possible to make an array of strings, just like you can make an array of integers. You just use string on the outside there, so it's string and then square brackets. The thing that makes something into an array is the square brackets. When you create one, you're going to do the variable type, which is string or int or double or bool. You could have an array of booleans, that's possible. They could also be bigger things like dogs or students or something else, so you could have student square bracket, and that would be an array of students. and then the variable name equals new, and then whatever that type is again, this time in the square brackets you put in the size that you want. And again, this is us just putting some values in there and then using a for each loop to iterate through them and print them back out again. The alternative syntax for putting values in, this is something I showed you a few minutes ago. This is just a way of putting values in. This is an array of doubles, so double grades equals new double square brackets, and this time the first grade is 92.8, the next is 78.4, and the last is 44.6. If you're doing this syntax, remember you don't put a number in here, and you just put the values inside of curly braces, comma separated. This is calculating the average of those, and so what it's doing is it's first calculating the sum of them using a loop that's going from I equals 0, I less than grades.length. Since there are 3 values in here, grades.length will be 3, so that's I equals 0, I less than 3, I plus plus, so that's going to do 0, 1, and 2, which is going to take the value of cell 0, which is 92.8, add it to sum, the value of cell 1, which is 78.4, add that to sum, so now you're at about 160, and then take the value of grades at position 2, which is 44.6, and add that to the sum. That gives you a sum total of the 3 values added together, and then you divide it by grades.length will tell you what the average is, because that's how you calculate an average. Alright, so what happens if you need to resize an array? If you create an array, but then you later realize that you actually need a bigger one, well, the only option is to do what the ArrayList was doing manually for you. What the ArrayList was doing automatically for you, you're going to have to do that manually. So you'll create a new array with the new size, and then you'll have to copy all the content over. So here we create an array of 3, size 3, that's going to hold ages. We put in 30, 40, and 50. Then we realize we actually need more than 3. So we create a new ages, which is size 6, and then we use a loop that says for I equals 0, I less than the original array's length, into new ages at I, set whatever is in ages at I, and so that's going to take cell 0 and put it in cell 0, cell 1 and put it in cell 1, cell 2 and put it in cell 2, and now you can change the name of the final array to ages at age, and now you'd be able to insert a new value. So this is kind of painful, but that's what ArrayLists do automatically for you in the background. What happens if you want to search an array? In Python you could just say if this number is in the list, and there's no real equivalent keyword for that in Java. You kind of have to just do it with a loop, which in fairness is what Python is doing in the background as well. So you say for I equals 0, I less than the array length, I plus plus. If the array at position I is equal to whatever it is you're searching for, then you print out you found it and you break. The reason for the break is because there's no reason to keep looking if you've already found it. Once you hit the first element, that is the thing you're looking for, you can stop. It's kind of like when you're searching for your keys in the morning. Once you find them, you can stop looking. So that's what that break is doing. You could leave the break out and it would work. It would just do more work. All right, printing arrays. So another thing that Python does really nicely for you is if you print a list, it goes ahead and prints it out with the parentheses around it and everything so that you know what's inside of the list. Unfortunately, if you print a list, an array in Java or an array list, you'll have the same problem there. You're just going to get something that looks like this. So what I did here was I created an array of integers. I set some values in it. That's the other shortcut for this, is that you can eliminate the equals new int because it knows what you're doing. So this is a shortcut on a shortcut. And then I am doing print of that array. So since this is an array, Java doesn't know how to print it. That's not something it automatically knows how to do. And so it gives you this weird output. When you run this, you'll actually get something different. It'll be I at and then some random set of numbers and letters up to F. So A, B, C, D, E, and F. Very specifically, if you care what this means, this is the address in memory where the array is actually stored. Every little bit of memory that you have has an address, just like mailboxes have addresses or your house has an address. Every single bit of memory has an address, and the computer has to keep track of all of that. And so when you print out an array in Java, what it actually tells you is where exactly it's stored in memory, which is probably not what you want. If instead what you wanted was to print out the values in the array, that's most likely what you were trying to do, then you'd use a loop. For I equals 0, I less than the array length, I plus plus, and then you would print out the value of the array. So here what we do was we start off with a string called output, and we set it equal to a square bracket. We're going to print these out, make them look just like they do in Python. So we have that square bracket, and then as we're going through it, we add to the string output each of the values in the array and a comma, as long as we're not at the last one. And then at the very end, we add a square bracket, and then we print that output string to the screen. It's hard to see that last bit because of this bar, so let me move it. You print that output to the screen. So that will give you square brackets 1, 2, 3, 4, 5, the values that are inside of the array. So this is the same code as print list in Python. So obviously Python is a lot easier in that regard, but again, in fairness, what Python is doing is this in the background. It's just you don't have to remember to type it, you just have to do it more manually here in Java. A couple of things about this that are interesting. This is something we haven't mentioned before, but this is a string. Output is a string, and you're allowed to do plus equal on a string, which allows you to add items onto a string. Whatever is there previously, you're adding a new item. You've seen plus equal with numbers, so if you have a value that's currently 7 in a variable called x, and you do x plus equal 10, it'll now be equal to 17. You're adding on. But in the context of a string, a plus means that you're concatenating a new value onto the end. You're stuffing a new value in there, and so in this case it's adding in each of the values to the string, and then this is adding in a comma to the string so that you're getting the nice formatted output. Alright, and likewise if you want to compare two arrays, again, Python, you would simply say if the string or list is equal to the other list. There's no such way to do that in Java. You're going to have to write a loop again. And so this does not work. What's up at the top? Instead, what this is doing is it's checking if the arrays are of different length, because if they're of different length, then obviously they're not the same. But assuming that they're the same length, then we're using a loop to go through and compare if each cell of the two arrays are equal. If they are not equal, we know that they are not the same, so we break. If we get all the way through the loop and they're still equal, then we know that they are the same. Slicing arrays, likewise in Python, you had the ability to say, I want from this cell to this cell in an array or in a list. There is again no such way to do that in Java. You have to make a new array and copy the bits that you want into the new array from the old array manually, and that's what's happening here. So what you're noticing here is in Java, almost everything you do with arrays is going to involve a loop. You're almost always going to use a for loop, because for loops are designed to do something a set number of times, and an array is a set size. So they go well together, right? An array is 5 elements, and you're going to use a for loop that does from 0 to 4. And that's going to give you 5 elements worth of work, whatever it is you're doing to it. So slicing, searching, sorting, anything like that is going to involve a loop. All right, Java arrays are objects, so you can also use some built-in functions. So there are a couple of functions that make life easier. So here we declared 2 arrays, and then we can do arrays.copyOf, which will give us a copy of an array. That makes 1 copy. So that's similar to that loop. It's a built-in function for doing it. You can do array to string, and that's going to give you a printout of some of the values in the array. It'll give you a printout of the values in the array. Arrays.equal will tell you if 2 arrays are equal. So there are some built-in functions, but you'll notice that they're called via arrays dot and then a function, and then you pass it an array to work on. So kind of weird. The last one in there that I didn't mention is a binary search, and that does a search through your array looking for something. Alright, and the next thing to say is that arrays can be of type object as well. So if we have a class trophy, you could have an array of trophies. So that's done with the name of the type, which in this case is an object, square brackets, and then a variable name. Each cell of this array would be able to hold a trophy, whatever a trophy might be. And so you can then create an array of a specific size. What we're asking is how many trophies do they want to store, and then we say equals new trophy, and then the size that they gave us to say how many we're going to create. The final thing we're going to mention about arrays is that a nice thing is that they are allowed to be two-dimensional. So this is something that you don't really have in Python. You can make a list that inside of the list it contains other lists, but honestly that's kind of clunky. Java and most other languages support the ability to have a two-dimensional list. So what's happening here is instead of one set of square brackets after the word int, I put two sets of square brackets. So int square bracket, my int array equals new int 10, 10 in square brackets. What this creates for me is a two-dimensional array with 100 cells. So if we go back out to our handy dandy little picture here, which I promise I erased, I did, what that did was, I need to go to pen mode, it created for us a two-dimensional structure. Each row is one of those dimensions, and each column is another one of those dimensions. Now, in this particular case, I'm going to run out of space, but 0, 1, 2, 3, 4, 5, and 6, 0, 1, 2, 3, 4, and 5, I'll make it at least square. This would have been an array where you would have put 6, 6 in the square brackets at the end. Sorry, not 6, 7, because this is an array of size 7. So you would have something that looked like this at the end of the declaration of the array. And each one of these cells, this is a cell, that's a cell, that's a cell, has an address. And the way that a two-dimensional array works is you always specify the row first and then the column second. So for example, if I want to put something into, let's imagine this cell right down here, I would say, assuming that this is called my array, let me shrink this down just a little bit so I have a bit more room. There we go. Oh no! I erased stuff because I had an eraser. I hate it when that happens. Okay. I'm going to draw those back in real quick. Sorry about that. Doop, 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 doop. Okay, so something like that. So the cell that I have here, the way that I get to that cell is I would specify it as cell 3, so I would give the number for the row first, and then 4, which is the number for the column. So very specifically what I would do is I would write, assuming that this array is called my int array, I would do, oh, that is just not working, my int array. All right, and then I would specify the 3 for the row, and then the 4 for the column, and then I would set that equal to whatever value I'm trying to put in there, so I'll put in 56. And the effect that that's going to have is that that cell that I had an X in previously is now going to have a 56 in it. Okay, so that's how you specify things in a two-dimensional array. They're just automatic. That's one of the cool things of Java, is that you can have a two-dimensional, a three-dimensional, a four-dimensional, a 19-dimensional array. It gets hard to draw after you get past 3-dimension. If you want a third dimension, picture a cube where there's, depth back behind this, and each one of these two-dimensional arrays is stacked on top of each other effectively. And in that case, you do row, column, and then the third dimension, the z dimension, to specify where you are. So two-dimensional arrays are really handy. A lot of things in the world kind of look like a two-dimensional array. For example, if I have a board in a game, like let's say chess, you'll notice that it kind of looks like this pattern that we have down here. It is a very similar thing to a two-dimensional array. And so very often board games are going to be in a structure that looks something like that. And you're just going to have each one of these be a cell that holds a piece. So it'll be a two-dimensional array of chess pieces. And they can either be empty, or it could be a pawn, or it could be a king or a queen or a knight or whatever else. Checkers, same thing. If you think of most board games, they usually have a grid pattern on the bottom, and that's generally implemented in code with a two-dimensional array. All right, working with a 3x3 array here, you'll notice that if we're going to do something in a multi-dimensional array, a two-dimensional in this case, you're probably going to have two loops, and they're probably going to be nested. So we created an array of size 3, 3. So this is a 3x3 grid, so there are 9 cells in here, 3 rows, 3 columns. And in order to work through this, to do something like put values into it, what we're going to do is we're going to have an outer loop that moves us through the rows, and then we're going to have an inner loop that moves us through the columns. And so int I equals 0, I less than the length, I plus plus, j equals 0, j less than the width. That's how you get to the width. You ask for the length of one of the rows, plus plus. So that'll be 3 and 3 in both of these cases. So the inner loop is going to do something to the array at cell 0, because that's what the I is, 0. And that's going to be equal to some value. The next iteration of the loop is going to change the j to a 1, so we're going to be looking at cell 0, 1. Then 2, cell 0, 2. When we reach the bottom, this goes to 3, which is now no longer less than the length of the list, so this loop exits, which brings us to here, which causes us to go to the top of this loop, and this loop is going to move on from 0 to 1. When it moves on to the next line of code, it's going to start this loop over again, because we've never seen it now. J is 0, so this time it's going to be 1, 0, 1, 1, and then 1, 2. And again, when this gets to 3, the inner loop exits, we go to the outer loop, and I goes to 2, at which point we now can put something in 2, 0, 2, 1, and 2, 2, which is the last cells. So that's how you're going to work with a two-dimensional array. You're generally going to have a nested loop like this, one that deals with the row, one that deals with the column. And these do have to be in here, inside of the other one. The one that's dealing with the columns has to be inside of the one that's dealing with the rows, because you do want to do each column on each row. So you're going to have to do 9 things to fill 9 things into 9 cells, because it's a 3 by 3. If you want to print out one cell, that's how you do it down there. So that is how you deal with two-dimensional arrays in Java. They are very handy. You're going to run into them. You're going to see them in labs here in the next week or two. And that completes our lecture today. So today we have dealt with array lists, we have dealt with strings, and we've dealt with arrays. And you should be starting to get a feel for the basic syntax of Java. A lot of it is very similar to what you've been doing in Python, but there's some stuff that's a little different where things are laid out and curly braces and semicolons and stuff like that. So I will see you guys in the next video. Bye.